Hey everyone, and welcome to this first recorded 1B class. I know the last one I didn't record anything, mostly because all the information was just there. You didn't really need me to talk through it. So you can view the PDF of that in our Schoology folder. But today we are going to recap on some of our Unit 4 material from the factoring unit. And we're going to look at just kind of a general, let's recap on what we did in this unit, and then I'm going to go specifically into the adding, subtracting polynomials and multiplying polynomials. We're going to do a quick recap. So we're going to do adding, subtracting, multiplying today. Tomorrow we'll do factoring, and then we might do another day on solving, and that should get us up to speed, ready to move on to some of the newer stuff that we're going to do in this unit. But I do want to make sure we're recapping first. Essential questions for today. What do I need to remember to do when subtracting polynomials? So what's that special step that a lot of us forget to do, we need to remember to do? And then when we're multiplying polynomials, what's some strategies we can put in place to make sure we don't miss doing any terms? So we'll kick it off with a Kahoot in class. If you would like to play, you can actually find the link in Schoology and just play it on your own and see how did you do. This is a recap of our Unit 4 material so far. All right, adding polynomials. So the key to remember here is that when you are adding, you're just going to drop the parentheses. There's nothing else to do with them. So when you think about your order of operations, parentheses will come first. There's nothing to do inside of either of them. So then we can actually just drop them. So we've got 3x plus 5y squared plus 4x plus 3y minus 2y squared. What I like to do is grab my highlighter and highlight terms that have the same variable in the same degree. So we have 3x, that's an x to the power of 1. There's one other term with an x to the power of 1. I've got 5y squared, and there's one other term with a y squared, and then I've got this one term with y to the power of 1. So then the terms that have the same highlighting I can combine together. So I've got 3x plus 4x is 7x. I've got 5y squared minus 2y squared is going to be positive 3y squared. And then I've got a 3y that had nothing else to combine with. When you're writing your answer, you should write it in the degree order. So that means the highest exponent is going to go first. So in that case, it's going to be 3y squared goes first. And then 7x and 3y are both to the power of 1, so it doesn't really matter what order I put them in. I'll usually defer to alphabetical if I have a choice. So x would come before y, and that's all that really is to it. So combine your like terms and make sure that you're watching out for those positive negative symbols. So like the minus 2y squared, just make sure when you highlight that you're grabbing that negative with it. Okay, so you can see the important part in bold up top. Don't forget to distribute the negative. You are subtracting an entire polynomial from another one. So everything inside the parenthesis needs to change sign. This negative is actually distributing to all of the terms inside of it. So this 4x is going to become a minus 4x. The negative 2y is going to become positive, and the 7 is going to become negative. Then write your terms out again. 3x plus 6y minus 5 minus 4x plus 2y minus 7. And then it's like last time, get your highlighter out, like terms, give them the same highlighting, so 6y and 2y, and minus 5 and minus 7. So then 3x minus 4x is minus 1x or minus x, 6y plus 2y is 8y, and minus 5 minus 7 is negative 12. Nothing to change on the order here, so we are done. So the key part is distribute the negative. And I like to change the sign underneath and maybe put a little circle around it so it's like, hey, don't forget, Mr. Phelan, you got to change the signs on these when you write them out, and then you can add them together. So here are 3 ones that you can take a shot at. We'll be doing these in class. What I want you to do with the video is to pause it, do the questions, and then unpause it to see the solutions. So pause the video now and then come back and you can see how to do it. Okay, so hopefully you've tried all these yourself. Let's go through them together. First one, 4a squared plus 3a minus 7. It's a plus, so I don't have to change anything. And I got 2a squared minus a minus 9. So nothing's going to change about these. So I can just write them out and grab my highlighter. Okay, 4a squared and 2a squared. I've got a 3a and a minus a, and then I've got a minus 7 and a minus 9. So 4a squared plus 2a squared is 6a squared. 3a minus a is 2a. Minus 7 minus 9 is minus 16. So that's our first one, done. The second one, we've got 4 terms minus 2 terms. So first thing, subtract a polynomial, which means we've got to distribute that negative and change our signs. And write it out again. So I got 6b cubed minus 2ab plus 4b minus 5a minus 10ab minus 4b. So remember, unless all the letters match in a term, you cannot add them together. So like 6b cubed, there may be b's in some of the other ones, but they don't match. They don't have the same degree. 2ab, so ab is the variable, that's the term. So I can't combine it with just b or just a. There is another ab though, so I can combine it with that one. Then we've got 4b. There's another 4b, or it's a minus 4b, so those are going to cancel. And then we've got a minus 5a, which is a term on its own. So we'll have 6b cubed minus 2ab minus another 10ab. So we're subtracting minus 2 and then taking another 10 away. This one can always trip people up. So imagine your number line. We're at 0 here, so we got minus 1, minus 2. If you are subtracting, so wherever number you're starting with, if you're subtracting, you are going left on the number line. You are taking numbers away. So we're taking another 10 away. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are going to end up at minus 12. So just remember, if you are subtracting, you're going left. If you are adding, you are going right from that starting number. That's always a little trick for kind of remembering what you're doing. It does get confused sometimes with multiplying, and I'll put it in here just to have it in one spot, but please don't get them confused. If you multiply two positive numbers, you get a positive. If you multiply two negative numbers, you also get a positive, and if you multiply a positive and a negative number, you get a negative. So this is the one I think that trips people up because they're like, oh, I've got minus 2 and minus 10. That's a double negative, so I'll get a positive. It's not true. Think about what you're doing. You're at minus 2. You're taking another 10 away. So you're going left 10 on the number line. Okay, so minus 2 minus 10 we said is minus 12 AB. We got 4b minus 4b is 0b. So the b's are gone, so I'm just going to cancel those out. And then I've got a minus 5a at the end. And that's it. We're done. The last one, this one has 3 different terms, a binomial, binomial, and trinomial, and we're subtracting both of them. So we're going to have to distribute that negative. So it's going to become minus 4x minus 6z. We're going to have plus 5x minus 2y plus 3z. So 3x plus 10y minus 4x minus 6z. Plus 5x minus 2y plus 3z. And let's get our highlighter out. 3x, 4x, 5x, 10y, and 2y, and I got a minus 6z and a 3z. Okay, so we got our terms circled or highlighted, whatever it is you're doing. There's no order that we have to follow because they're all to the power of 1. So we'll just do x's first because it's first in the alphabet. 3x minus 4x is minus 1, plus 5 is 4x. And then 10y minus 2y, so we're at 10, we're subtracting 2, we're going to end up at 8y. And minus 6z plus 3z. So you think of it, again, we're at our number line, we're at 3, 4, 5, 6, so we're at minus 6. We're adding 3, so we're going right 3. So we'll end up at minus 5 minus 4 minus 3. So we got minus 3z, and that's it. All right, multiplying, some things to watch out for. If they have the same variable and you multiply them, you're going to add their exponents together. So x to the power of a times x to the power of b will be x to the power of whatever a plus b is added together. So if it was a squared times a cubed, it would be a to the power of 5. So you add them together, 3 plus 2. If I do a times b, so they're both to the power of 1, they don't match, so I just push them together. So it'll be a to the power of 1, b to the power of 1. Okay, so then if we're pushing stuff like this together and there's still a lot in there, again, there's nothing common between the two things we're multiplying, so they're just going to squeeze together. And alphabetical order is generally the grammatically correct way to write it. If you had just kind of pushed these together, like just gotten rid of the multiply sign and just pushed them together, you still wouldn't have been incorrect though. All right, so we got 3x times 6y. You do the coefficients part, so the numerical part, 3 times 6, 18. X times y, there's nothing common there, they just push together. 4a squared times 3ab, again, 4 times 3, 12. Now, there is an a in both of these terms. So we have a to the power of 2 and a to the power of 1. So when you multiply these, you add those exponents together, and that's where we're getting the 3 from. And then b, there's nothing else to add to it, so it's just pushed in at the end. If you have something that does not have a variable, again, just treat it like a coefficient. 6 times 4, 24, the g stays there. All right, multiplying binomials, the key is everything in one parenthesis times everything in the other. So everything needs to be linked to the other one. I like to use these little arcs for doing that. So like x times x, x squared. X times 2, 2x. Minus 5x minus 10. So I get x squared minus 3x, because 2x minus 5x, I can combine those, and I get minus 3. 2 minus 5 is minus 3. And then minus 10 at the end. And that would be my final answer. So just make sure, x in the first parenthesis was multiplied by the x in the 2 in the other one. Minus 5 was multiplied by the x in the 2 in the other one. You never do x times minus 5, like in the first x and the first minus 5. That does not happen. So it's everything in the first parenthesis times everything in the other parenthesis. If it's slightly bigger, so like, there's more, there's actually still 2 times 2, binomial times binomial, but the letters are a little bit different. So let's just see what it turns out as. A times 2a, 2a. Now we got an a to the power of 1 times another a to the power of 1. Add their exponents, we get a squared. A times minus 4bc, nothing to combine there, so we just push it all together. So minus 4abc. 3b times 2a, 3 times 2 is 6, and then a and b are going to go next to each other. And then 3b times minus 4bc, we got minus 12. B times b is b squared, and then there's going to be a c at the end. There's no terms that are common, so we're essentially done here. Now, if we're going to put it in grammatical order, you would have like the a, b, c first, or the b squared c first, because they have a higher degree than the other ones, but we're cool with it this way for now. All right, this is probably as hard as it will get on your unit test. You've got a binomial times a trinomial, so just a little bit more to do. X times 3x squared is 3x cubed. So we have x to the power of 1, x to the power of 2, add them together, you get 3. X times minus 4x minus 4x squared. X times 2 plus 2x. 5 times 3x squared is 15x squared. 5 times minus 4x minus 20x. And 5 times 2, 10. So now we just have to combine those like terms together. So we got x's and x squares that need to be combined. 3x cubed plus 11x squared minus 18x plus 10 will be our final answer. All right, so our essential questions for today were, what do I need to remember to do when subtracting polynomials? This is when you've got a polynomial minus another one. We needed to distribute that negative to whatever is inside of the inside the polynomial afterwards. So you need to make sure, or inside the parentheses, I'm sorry. So whatever it is, change the signs, put that new sign underneath it so you know, okay, I need to change these signs, and then rewrite underneath it and add them together like they're a normal polynomial. When they're multiplying, draw those lines in. They're really helpful for just keeping track of what's been multiplied and what hasn't yet, and then make sure that you have the right number of terms as a result. If you're multiplying 2 terms times 2 terms, 2 times 2 is 4, so you should have 4 terms when you're done, and then you simplify it. If it's a 2 times 3, so like that last one we did, 2 times 3 is 6, so you should have 6 terms when you are done multiplying, and then you combine the like terms. For tonight, I'm going to give you a choice of worksheets, one for adding and subtracting, one for multiplying. I want you to practice on the one that you feel like needs the most practice. All right, I'll see you next time.